In this lesson, you will learn about a very important component which is used while working with your Arduino for prototyping. It's called a breadboard. You will learn what it is, how to use it, and the underlying construction of the board which affects how connections are made. You will also be introduced to some basic wiring concepts. In that way, you will be able to make the connection, no pun intended here, between how a circuit is drawn or represented and how it is physically wired up on a breadboard. Let's first address some basics about a breadboard. This tool helps us to quickly prototype our electronics projects because you can easily make connections between electrical components. This is beneficial in that we can easily decide if a circuit works and move things around before we make a more permanent solution, which is usually accomplished via a process known as soldering. Most breadboards have two power rails on each side of the breadboard. One can be used as a common positive rail for your projects, and the other for a common negative rail. Some breadboards have a break in the connection between the rails. If this is the case with your breadboard, you'll have to use a jumper wire to bridge the gap. The rows on a breadboard are horizontally connected, allowing us to make electrical connections between components. Let's take a closer look at our breadboard. On either end, you'll notice that there is a positive rail and a negative rail that are all connected vertically. And on this end, you can see here there's also a positive rail and a negative rail that's also connected vertically. In the middle of the breadboard, the pins are all horizontally connected. So on this end, these pins are all connected, these pins are all connected, and so forth. Similarly, on this other end of the breadboard, these pins are all horizontally connected. You'll notice that there is a break going down the middle of the breadboard. That means that these are not all connected. If you want to connect this particular row with this row, you'd have to apply a jumper wire. So let's see what this means from a practical perspective. If we look at our rails, if I put a connecting wire here and another one here along the same row, these wires are actually connected, they're joined. Because again, this entire row is one single connection. So these two wires are essentially joined together. It's like if they were one continuous wire. If, however, I were to place a connecting wire here, these wires are not connected. Because again, it's this entire positive rail is connected vertically and the other one is connected. So these wires are not connected to each other. At the center of the breadboard, if I put one connecting wire there and another one here, these wires now are essentially connected because again, in this row horizontally, this entire row is connected. So current would flow into this particular wire and then into the other one back out. So hopefully that gives you an idea of how your breadboard is wired. If you're still unclear, a little later on in the lesson we'll actually be wiring up a circuit, so you'll see this in action. Let's switch to the topic now of some basic wiring configurations. The first is a series configuration. Essentially, in a series circuit, the current is the same everywhere in the circuit. It comes out of the power source, flows through each component, and then goes back into the power source. Let's compare and contrast the circuit diagram to how it is actually wired on the breadboard. As you can see here, we start off at the positive of the power source and go into the R1 resistor. On our breadboard, again, here we start at the positive, and remember these horizontal rows are all essentially connected. So if a wire goes to any pin, any hole on this row, its connected via to this resistor. So essentially you are achieving the same concept. Power goes out, it goes into the resistor. Again, R1 here is connected to R2 because this row is horizontally all connected. So it goes into the R2 resistor, then into the R3 resistor, just like here. And then, since again this row is all connected, a wire from here on this row goes back to ground, which is the same on our diagram. So that is a series circuit, and the wiring that's on this breadboard is identical to the wiring that's on the series circuit diagram. Let's go ahead and wire up our series circuit. So it has our 3 resistors. So essentially we have a wire that's coming in. I'm going to connect one resistor here. It's going to span across a couple of those rows. Next comes our second resistor that's in series. And then finally our third resistor that's in series. And then we have our wire that's going to come back out to our power source. So if we look at our circuit, here is if we connect these two to our power source, current is going to flow down into this wire. Remember, this row is all connected horizontally into our resistor. This is all connected into our second resistor, into our third, and then back out. All right, so that's a series connection. The other circuit configuration is a parallel circuit. In this setup, the voltage applied to each resistor is the same, but the current splits up. Current leaves the power source and splits up, flowing through each resistor, here, here, and here, and then collects again before returning back to the power source. If the values of the resistors are different, the current flowing through them are different. However, the total sum of the current entering the resistance, coming into here, and being split up, is equal to the total sum of the current leaving the resistors, going back into the power source. This is known as Kirchhoff's current law in electronics. Let's compare and contrast the circuit diagram to how it is actually wired on the breadboard. So here you'll see from the positive of our battery, there's a connection. Remember, this rail is all connected. So here is our R1 resistor, which is connected to our R2 and our R3. So here the R1, R2, and R3 are connected along this horizontal rail here. And then the ends of the resistors are all connected. So R3 is connected to R2, which is connected to R1, which that's the case here, since this horizontal row is all connected. And then we go back to our battery. So there you have it. That's a parallel circuit, and again, the wiring on this breadboard is identical to the wiring that's on this circuit diagram. Let's go ahead and wire up our parallel circuit. So first we have a wire that's coming in, connecting wire. Then we have one resistor. It's going to span a couple of rows here. And I'm going to put in a second resistor. And then the final third resistor. Finally, we have our other wire that's coming back to the power source. Right, so if we apply our power source here to the circuit, essentially current is going to come in from the power source. When it reaches here, remember this horizontal row is all connected. The current actually splits three ways. So it splits, some of it goes down to this resistor, some of it goes to the other, and then the rest of it goes to the third resistor. If these three resistors are the same, the current going through here would be the same. It would be the total current that's coming in divided by 3. It would go into each of the resistors. And then coming out, remember this row is all connected, so these resistors are all connected. The total current that's leaving here is going to be equal to the total current that's coming in. That's Kirchhoff's current law. So this is your parallel circuit. To summarize, you should now understand what a breadboard is, how to use it, and why it is important in prototyping. It really is an indispensable tool for us. You were introduced to the basics of series and parallel circuits, and how a circuit diagram is actually physically wired up on a breadboard. Making that mental connection of understanding the connections needed on a diagram and how that is physically represented on a breadboard is sometimes a hurdle for beginners. But if this is new to you, don't be alarmed. Pretty soon you'll get the hang of it. That was quite a lot of information, but definitely needed as we progress in our journey so that you will understand what is taking place as we wire up circuits in our upcoming projects. Let's move on to the next lesson.